Sure, absolutely. You guys can do the jinx, beat each other, whatever thing. So, at least 2 kings. Now, it looks like we're picking 4 cards. Are we using the whole deck? Yeah, so this isn't the one where they pulled the face cards only out? Okay. So the first thing I would say is my approach is going to involve a bucket. I have kings and not kings. How many kings are in the deck?
4.
How many not kings?
48.
Have I got the whole deck in there? Check. Okay. Now, read the question to me. What does B want? Stop. As soon as I see at least or at most, my spidey sense starts a tingling. This is a trigger. I'm going to have to list the cases, and I'm going to clue in. This is going to be a trickier question. At least what?
2.
Which means what? I'll give you a hint. 2 or
3. 4.
I could also go all of them minus 1 or none. You know what? Calculating all of them, 1 or none, that's 3 operations. This is 3 operations. I use the complement only when it's obviously way, 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 way shorter, because I might make a mistake. Okay, so if I pick 2 kings, how many non-kings? So the first group is going to be from 4 kings, choose 2, and from 48 remaining, choose 2. Or, did you just figure it out now? It's going to be 3 and 1. Or from 4, none. By the way, I know that this right here works out to 1, because anything choose itself is 1, and anything choose 0 is 1. Okay? You can absolutely expect a card question, and you can absolutely expect an at most or at least question on your test, and it may be a card question with at most or at least. Any others? What did you do, by the way? What was your zig? Oh, there you go. Good. Ready? Look up, look up, look up, look up. Everybody, calm you too. Built-in error check. How many cards are in a deck of cards grand total? How many cards are you picking grand total? No, how many cards are you picking? Can you see a little built-in error check that you can use? The front better add to your total deck, and if it doesn't, you've missed something. The back better add to the total number of cards, which is why even if I'm choosing 0, I still write it because that symmetry still works. I still have my 52 cards, and I'm choosing 4 of them. I really like that symmetry, even though normally I'm lazy and don't write extra things because I know anything choose 0 is just a 1. I'll write it out as an expression because it gives me that built-in error check. Handy trick. Any others? 5C? Okay. 5C. 5 movies. There are 14 different movies available. 10 disaster movies and 4 horror movies. How many possible schedules include? Now, I'm looking, it looks like it's just saying watch it or not. I don't think it cares when I watch it. Okay? So, I'm going to use a bucket. Now, I have disaster and horror. Normally, Darian, I'd have 10 and 4, except what kind of a movie is this? Okay, they tried to make it pretty clear. So, you know what? I think now, if I have to watch, I got to watch Airport Disaster, and I only got one way to pick that. I got to watch Halloween Horror. I only got one way to pick that. And you know what? I think it means I have 9 left, and I have 3 left. Is that okay? Now, has it given me any other restrictions at all? You know what, then? I don't think for the remainder it wants me to distinguish. I think for the remainder it says, hey, how many movies are left? 12. See it? Choose. How many more movies am I going to watch? So I'm watching 5. I've already picked 2. How many are left?
3.
Can you see? Is 12 choose 3 the answer? I hope. Okay. And you may have noticed, Pam, the actual math here isn't tricky. The setup is the tricky part. And so that's why I've been yelling at you in love, but I've been trying to give you the tools. Draw a blank. Some of you that have come up and asked me a question, Mr. Dueck, how do I've looked? You haven't drawn a blank or a Scrabble bag. I won't help you. If it's a combination, draw a bucket. If you haven't drawn a bucket, I won't help you because I've given you a tool that usually will help bail you out, in theory, I hope. Any others from the homework? So Wednesday, I'm going to be checking all the way up to and including this lesson. Wednesday, I'm going to be giving you later on today a take-home quiz. That's going to be part of your homework as well as today's lesson. Wednesday, you're also going to be doing a practice test. It's going to be lesson 8. But Wednesday, I'm not going to be showing you anything new. But today, I will be. Can you go to lesson 7, please, which is page 107. Problem solving with permutations and combinations. And I think someone was away the other day, a couple of days ago, said, Mr. Dueck, I'm having trouble with this. I'm hoping this might clarify things because these are going to be nasties. So hopefully it'll make the less nasties a little clearer. I guess this question also, Ashley is saying, we'll have to figure out whether it's a permutation or a combination or a fundamental counting principle or something. Review. This is what I have on your formula sheet, I think. So review from earlier lessons. The fundamental counting principle, the number of ways is multiply. Factorial notation. Permutations, which is also defined as n factorial over n minus r factorial. Permutations with repetitions. So hopefully all of these mentally should be familiar to you. Oh, and choose. Note, one of the first things I want to figure out is, does the order matter or not? So that's why I've tried to give you some trigger words. Arrangement means the order matters. Permutation means the order matters. Example 1. Ty, can you read to me example 1, please, kiddo?
How many arrangements?
Stop. Underline the word arrangements. This is going to be either permutations or fundamental counting principle, drawing a blank. I know it's not choose, no bucket. Keep going.
How many arrangements of the word poppies can be made under each of the following conditions?
Okay, what's the first condition? Read me the next one.
Without conditions or restrictions.
Without restrictions. Okay. How did we do these? It's a word. What do you notice about this word? Some letters repeat. Okay, I'm on familiar territory. What factorial is going to be on the top? Over. Okay, so with no restrictions, can you crunch that, please? $840? Absolutely, you can expect to see that, a question like that. I'll give you a word with some letters repeating, and how many permutations, how many arrangements, how many ways are there to rearrange, how many ways are there to mix up? Okay. Now, let's get a little nastier. Jake, can you read to me B?
If each arrangement begins with B.
Begins with a what?
B.
Okay. So here's what I'm going to visualize. Let's see. What does it have to start with, Jake? So I have to have a P. Now, because this is a permutation, up here, I'm going to draw my Scrabble bag as a visual aid. And you notice I kind of try and randomize the letters a bit. What has to be in the front? We've picked one. Now, it has to be there. I know there's 3 P's to choose from, but I'm not going to put a 3 in the, in fact, you know what, let's put the P down here. 1 P goes in the front. I know there's 3 different P's, but would those form 3 different words? If I have a different P in the front each time, does that make a different word somehow? Okay, so I'm going to put a P there and draw a big vertical line. Pick the P. Maybe that one. So now, are there any other restrictions? And we're still making arrangements of words? How many letters are left? Any repeats? Oh, what factorial over what factorial?
6 factorial.
Because we used up 1 P already. See it? It's nasty, but hopefully when you see it, it's, oh, okay, yeah, that makes sense. I'm going to erase this red line because I'm going to keep reusing my Scrabble bag, but what do you get? I think I do some 360?
Yep.
I cheated. I glanced at the answer. I didn't do that one in my head. That was completely fake. Okay, now that you saw how we did B, what about C? The first 2 letters are P's. And I've got to put them there. So it's not going to, no matter what different P's that I put there, that's not going to give me a different word. Can you visualize the Scrabble bag now if I put 2 P's in the front? How many letters are left? Any repeating? So are you saying it's going to be, right? 5 factorial, I know. 4 factorial, 24 times 120?
Yep.
That one I did do in my head. Okay, if all the P's have to be together. That's really what I have. That's really what I have. Piezo. Now, we did questions like this earlier with the fundamental. We did a question, I think, where we had boys and girls. But there, I counted each girl as different. So when we had the 3 girls had to sit next to each other, we called it girl 1, girl 2, girl 3. And we said there was 3 factorial ways to mix up this weird Scrabble tile. Are these different objects here? No, you know what? It's going to be one of those. And I got an IESO. Nope, we're wrong. Okay. This also is a Scrabble tile in the bag. How many Scrabble tiles do I have in the bag grand total? Right? Yeah, I would drop something too. It's that profound. Thank you for choosing to help me emphasize that, Zach. Thank you for having the lid on there too. Okay? So here, we're still falling back on the fundamental counting principle. Except in this case, instead of 3 separate letters on that weird Scrabble tile, Julia, I've got 3 identical letters, so it's 1 Scrabble tile and then 4 more normal Scrabble tiles, 5 factorial. Now, what if that big uber Scrabble tile had 3 different letters on it? Well, then I would times it by 3 factorial because you can mix it up that many ways too. The first letter is P. The next one is not P. Okay. First letter. What's it have to be? Let's put a P down here. Got to have one of those. The next letter is not a P. What letters does that mean, actually? O-I-E-S, or IESO if you chose to go with my version. How many choices do I have for the second letter? Right? Okay. Have I taken care of the restrictions? This is complicated enough. I'm going to resketch a Scrabble bag over here, I think, Chels. P-O-P-P-I-E-S. So we said the first letter is a P. Let's say I used that one. The second letter is not a P. Let's pick a second letter that's not a P. What do you want to pretend that we used? S. So now I have that. How many letters? 5. Any repeats? So it's going to be times what? 5 factorial over 2 factorial, although 2 factorial is just 2. Oh, so it's going to be 1 times 4 times 5 factorial over 2 factorial. If you find these tough, you're normal. But hopefully as I go through them, hopefully you're starting to spot an approach, a way that works. What do you get? 240? Anybody else? Brennan. Oh, yeah, okay. So, poppies. Now we're adding way more restrictions. What's my strategy? It's an arrangement, so I can use Scrabble tiles. I can use drawn a blank. And along the way, I can pull out some factorials and some shortcuts. From the page. Example 2. Class consists of 5 girls and 7 boys. I'm already starting to think maybe this is a committee bucket question. I don't know yet. A committee is to be formed consisting of 2 girls and 3 boys. Determine the number of ways a teacher can choose the committee if A, there are no further restrictions. Now, that's a trigger word. What letter does the word choose begin with? This is an NCR. Also because it seems, Mac, if you read the question, all we care about is are you on the committee or not? So what's going to be my strategy here? Bucket. I got girls and boys, 5 and 7. 12 students altogether. How many girls are we choosing? How many boys are we choosing? What's my expression going to be here? What choose what? What choose what?
5 choose 2 times.
And,
No,
yep, times.
Choose 3.
Right? Remember, this is why I'm saying and means multiply. 2 girls out of 5 and 3 guys out of 7. Which is what?
350.
350, anybody else? Yep. B. Johnny, the principal's son, has to be on the committee. Does it say when he's chosen or just that he's on it? Okay, now my bucket's going to have 3 groups. I'm going to have girls, boys, and Johnny. How many Johnnies, the principal's sons, are there?
1.
How many boys are left in the rest of the bucket? And we deliberately picked a gender stereotype name. We didn't pick one that you can't tell whether it's a guy or a girl. So, and we added the principal's son on male. So 6. How many girls? 5. Okay, there's my setup. How many Johnnies have to be on the committee?
1.
How many boys? Well, 3, except we've already picked Johnny. So, 2. How many girls? 2. Hopefully, can you see the equation? What choose what? What choose what? What choose what? 5 choose 2. Still 2 girls. But from the 6 remaining boys, choose 2 of them. And from Johnny, choose 1. By the way, do you know what 1 choose 1 works out to be? 1. But notice again, Dom, my built-in error check works. How many students grand total? 12. Add up the front. How many are we picking on the committee? 6. Oh. Sorry, I put a 3 there. Thank you. There, built-in error check. For a reason. What do you get? 150?
Yep.
C. The twins, Peter and Paul, can't both be on the committee because the teacher can't tell them apart. I can relate in my Block H physics. Now, this is not saying none of them can be on the committee. What this is saying is if Peter is on the committee, Paul can't be. It's kind of mean, but okay. Maybe they don't play well together. Maybe they can't stand each other. Or if Paul is on the committee, Peter can't be. I guess I could look at all the committees with Peter and not Paul, or add all the committees with Paul and not Peter. I could have a 4-group bucket. Girls, boys, Peter, Paul. Okay? Or, if I was really clever, I could say, you know what? Why don't I find out how many ways they can both be on the committee and subtract that from 350. That'll tell me how many ways they both aren't on the committee. Okay? Kind of go like that. Method 1. Girls, boys, PE for Peter, PA for Paul. Okay. How many girls? How many boys? Well, originally 7, but now I guess it's 5, 1 Peter, 1 Paul. So, what's the restriction?
One of them can't be on the committee if the other one is.
They can't both be on the committee. So that means either Peter but not Paul, or Paul but not Peter, or what's the third one that satisfies this? Neither. Okay? So, we'll have Peter, underneath that Paul, here we'll do neither. And then we'll add them all up. I think we can continue to reuse the same bucket. So if we want Peter but not Paul, that's going to be, change colors, Mr. Dueck, let's go black. Peter, not Paul. Right? How many boys? I want to choose 1. How many boys do I have to have on the committee grand total? 3. How many do I have right now? So I need to choose 2 boys and 3 girls. So if I want Peter but not Paul, I'm going to end up with 5 choose 3, 3 girls, 5 choose 2, 5 boys? Yeah, that's right, because I have 7 altogether. Isn't it 2 girls? 2 girls, I'm sorry. Who pointed that out? Julia? Or did Madison say it? Madison. Mackenzie, say it first. Well, actually, it's Gobstoppers, and I got enough for both of you to each have one. I'll get them out later. Okay. 5 girls, choose 2. 5 remaining guys, choose 2. And Paul, choose him. Or Peter, choose him. Paul, don't choose him. By the way, what's 1 choose 1?
1.
What's 1 choose 0?
1.
Also 1. Okay. But my built-in error check works. What about Paul? You know what? I think the only difference is that's going to be 0 and that's going to be 1. Right, Brianna? I think. In fact, I think it's going to be the same expression in a slightly different order, but it's going to be 5 choose 2 and 5 choose 2 and 1 choose 0 and 1 choose 1. If you were really clever, you could just do the first line, hit equals, and then times it by 2, because I think you're going to get the same answer. Neither. None. And I guess that means pick 3 boys from the 5. Five girls, still choose 2. From 5 boys, choose 3. From 1 Peter, choose none. From 1 Paul, choose none. Add them up, what do you get? According to my answer key, we should get Did you get 300? Do you want to practice this on your calculator? Now, in terms of level of difficulty, I would consider this an A-, maybe even an A-level question. Okay? So if you're wondering, in terms of the test, is this fair game? As a nasty, sure. 10 of these, no. 1 of these, sure. What about using the complement method, Mr. Dueck? Yeah, we get there as well, but I think the complement method requires me to figure out 3 things as well. We got there doing this way, listing all the possibilities. I think we're good. David, Stephen, and Helen were trying to answer the following homework question. Okay. Students in a school band have practiced 5 popular and 6 classical music compositions. Got it. 5 P's and 6 C's, maybe. For a school program, they will choose... For a school concert, they'll choose a program consisting of 3 popular and 2 classical music compositions. Okay. Now, it does say choose. Does that mean this is a combination? Oh, wait a minute. There's something that overrules that. This last sentence says, if the order of the composition matters. This is going to be a permutation, arrangement, fundamental counting principle question. That trumps my, oh, choose means C. Determine the number of different programs which can be presented. David's, well, here's the answers. Which of these must be wrong? Why? Okay. I think there's another one that has to be wrong as well. Why David?
Because it's he added both popular and classical music.
What question is he answering, by the way? How many ways we can play any 5 songs in any order? Oh, by the way, what you're also talking about here in this particular is the shuffle button on your iPod or your MP3 player. That's a permutation. So if you have several thousand songs and you want to know how many, 10-song playlists it can generate with a shuffle button, the answer is far more than you'll ever actually be able to listen to in your lifetime. So David, didn't separate songs. Now here's my question. Is Stephen correct? Does that work?
Yeah.
Well, the only issue I would have with Stevens might be, I think he's assuming that we're going to play the 3 pop songs back to back to back, followed by the 2 classic songs back to back. Right? So, discuss the merits of each answer, indicate errors in any. I think Stevens is incorrect as well, because playing now that's a very subtle error. So the real question is, okay, if from 5 songs you're playing 3 pop songs, and from 6 songs you're playing 2 classical songs, and the order matters, how many different programs can you set up? Well, let's see. I think we have to somehow take into account that there is order, and order doesn't matter in certain situations. I'll show you what I mean. How many songs are we playing? Sorry? Definitely that many ways to play 5 songs. But now I have to choose the different groupings. How many pop songs are there? Grand total. How many pop songs am I choosing? Mr. Dueck, it says order mattered. Yeah, I've got the order mix-up right there. I'm saying once I choose my songs, I can fit them in 5 factorial different ways. And how many classical songs are there? How many am I choosing? So, if we don't have to play pop and classical back to back to back, if they can go in any order, but I'm also at random choosing 3 pop songs and 2 classical songs to fill up the program, how many different programs are there? 18,000. So here's some of the mathematics of MP3 player playlists, assuming you all have playlists based on either artist or song type or whatever, and you hit the shuffle button, and maybe you've wondered, how many ways are there to get this playlist going? By the way, full disclosure, the MP3 players aren't truly random when you hit the shuffle button. They're what's called pseudo-random, so it's not really quite accurate. What's your homework? Ta-da! Done the unit. Now he's awake. I think you can do number 1. Number 2, is it ugly? I think 2 is doable. Oh, this used to be my nightmare question, this tattoo question. Now, certainly 3. Actually, you know what? I'll let you try it. Tattoo. No, I don't want to see your tattoo. No. 4 is good. I don't know. It's called an attention span. I generally just write it up here and expect to copy it down. 5 is good. Pathway questions. 6 is good. Also a pathway question. Mr. Dueck, this homework is getting kind of monotonous. Oh, okay, 7 is good. Okay.
You get a laugh track on your computer.
Yeah, that's what I need. Jerseys, CFL, 7 NHL, 8 CFL. How many more am I going to get here? I think we'll try 8. We'll skip 9. We'll try 10.
There's 17 overall.
Must take English, either math or psychology, and then either 2 courses from Group A or 2 courses from Group B.
Physics is one of those courses.
That's tempting, but let's see here. 3 different shirts, 4 different ties, 2 different pairs of pants. I think 12 is good, because 12 is asking you to not solve it, but give the expression. I think 13 is good as well. 14 I'll pass on. 15 I'll pass on. 16 I'll pass on. At least 2 of each gender, so that means 2 girls or 3 girls. Yeah, you know what? 17 is doable. It's actually not as long as I thought. So, homework. First of all, your most important homework, I'd love you to try take-home quiz number 3. This is pretty close to a summary of everything. Yeah, I even have an at least or at most. I don't have... Oh, you know what? I do have one weird question. I don't have too many of the weird ones that we've done from today on here. That is absolutely due at the beginning of Wednesday. Now, on a Wednesday, I'm pressing pause. I'm probably on a Wednesday going to give you all class, all assigned certain questions from the practice test. And sometime by the end of class Wednesday, I would love it if you can show me lessons, 1 through 7. You got 30 minutes here, so I think you get it all done in class if you hustle. Okay?